So that was, I apologize to anyone that my wrestler driver plowed through. So one thing that we discovered is in order to ship the robot, we had this climbing cable that would tie to the climbing cable. And it was only until the last match that I said, why are we using the climbing cable, which you could get from REI, to safetyize it, and then the mechanism as a wire rope? Why don't we use climbing cable as the entire thing? As both the safetyizing of it and the mechanism itself. So one thing, metal wire looks cool. I think of it as a very cool thing, but boy, oh boy, go out to REI, buy some climbing cable. That will save you an awful lot of time. 488, the robot out there from 48 has the climbing cable on it. Okay, you could see that. So those are telescoping things. Unfolding rails. Unfortunately, I tried to get this a better picture of 948's unfolding rail, but they didn't respond to this. This is their robot in the starting configuration. So everything has to be folded up. They also use a track system. They use an elevator. But instead of a telescoping elevator that we've seen in the other slides, what theirs does is there's two tracks here on both sides here, and there's two tracks on both sides here. The start of the match, what they do is they take this, they pivot the whole thing up, and now they have a 10-foot piece of track going up and down. So instead of telescoping, what they've done is they just made the track one continuous track, just cut it in half, make sure that your track lines up, and then this puppy can go up and down the track all day long. They were monsters out there on the field. They don't have to worry about telescoping. You don't have that much chain. You just have to make sure that the tracks line up very well up here. We're still going very fast, right? Okay, well, we've slowed down a little. How'd you get a picture of a robot? Yeah. Well, I asked for a better picture of their robot, but they didn't provide me a. Thank God Eric Stokely is in my earlier class, so I could explain this to the later class. This is the 360 robot from last year. It's a cannon. What I mean by cannon is it throws things, and it threw balls. Huge, very large.
Big 48-inch diameter balls.
Yes, yes, yes. 10 pounds? 10 pounds of that?
7 pounds.
So what would happen is, unfortunately, since this is a bad picture, sorry, this scoop folds down in order to load the ball in. So it would run around with the scoop down until it got a ball into the scoop, and then it would raise up the scoop, and then the scoop got out of the way, right? So you lowered the scoop down. You can't quite see it, but these two arms here are on pivots right here. There's a piece of probably climbing rope. Is this climbing rope?
It's actually Spectra cable.
Okay.
We wanted zero stretch.
It's now climbing rope.
Okay.
The climbing rope goes to a piece of rubber tubing, and I'm guessing that that is just for assist, right?
Yeah, no,
so,
that was just keep the rope from getting tangled and everything.
From keeping, okay. But down here, there are two pivots, or there's two pistons. Are the pistons on top of the, I should have actually asked these questions before I had 40 people in the middle of the room. But
well, here, I'll tell you what, let's just do it.
Hey, yeah.
All right.
Hey, Eric, can you come over here and tell us how your robot works?
There's two pistons here, and they're laying down here, and they extend out that way, and they pull on a rope. Right? So when they extend out, they pull on a rope. The rope comes up here, and this piece right here then folds down like a mouse trap because of these two super springs down here. They're assists for picking up the back of a trailer. you know, to make the trailer lighter. So this would load it like a spring, or load it like a mouse trap. We had a latch back here that would slam in. Then the pistons would retract back in. That string would go slack. And then when we kicked the release, it would literally just mouse trap back out. The first time we fired it, my very first thought was, well, we need a safety officer. I never did the math on the springs, but easily arm breakers. I'm not sure I'd do it again, but it's so cool.
And this, you know, if you were in the rookie workshop and you were in my rookie workshop, oh, I remember those days, just a month ago. I mentioned that whenever you build a cannon, you have to make sure that any energy that you put into the cannon has to be released safely without any power. So their latch mechanism, you can release it safely by probably pulling on the latch while someone, you know, pushes on the mousetrap and release it safely. The story is that down in Portland, we had a robot come in that had built a trebuchet out of surgical tubing. It was a very dangerous machine because when the machine was powered off, there was no way to release all that energy that they had put in there. There was just an insane amount of energy on that. But they couldn't release it without power, and therefore we didn't actually allow them to be on the field with it powered. So they had to reduce their entire thing. So if you build something like this, where you are talking about garage springs or some sort of springs with latching mechanism, make sure that you can release all that energy safely on the field. So that is the safety part of it. So that is the 360 design. Now, the thing that you've noticed is that up until now, we've been sort of talking about what this year's game and last year's game is. I'm going to go back 2 years to Team 949's robot. Oh man, I remember this one well. We actually had this game. We were flinging these soft balls, or these foam balls, through a 9-foot, a ring 9 feet up. So a 3-foot ring, 9 feet above the ground. So what we decided to do is we decided to toss these balls up. So this is also another cannon, but instead of a mousetrap-ish type of thing that you saw sort of last year, if you paid attention to it, this has a big flywheel on here. So what we would do is we would kick the flywheel going really fast, and then these two elevators here, there's 2 elevators that could go independent of each other. We would just feed the ball up here. It would let gravity fall down into the flywheel, and we would just launch the ball up through here. So this one, since we have time, this one, we actually, there was a speed limit on how fast the ball could move out of here, and we were very close to that speed limit. The story is we had an old Boeing engineer who was just the most inappropriate person to have on a robot team ever. He was just, he cussed, he swore, but he was an old Boeing engineer.